Welcome back, geometry students, to another day of geometry. This is actually going to be the last day of learning or application of chapter 3, and so hopefully you're winding down your time doing that. And we have a test coming up on Friday. That's going to be Friday the 17th, and so today's lesson is actually rather short. It's just going to review a few ideas, and then you can practice that in your homework tonight. What I wanted to do, though, is work on a warm-up problem that really hit on this idea of writing the equation of circles, which is something that we struggled with on the last quiz and something that people have neglected to practice, I believe, since we last talked about it in person. So if you don't have it down, the equation of a circle that we are going to be talking about is this following thing right here: x minus h squared plus y minus k squared equal to r squared. And so this looks kind of complicated, and I just want to flush out some of the ideas. And that is that this h and the k represent the coordinates of the center of your circle. And so this was said in an earlier video, but I just wanted to reiterate. The center of the circle is at the point h comma k, and that's what those values represent in my equation. And the r right here at the very end represents the radius of my circle. And so this is an equation that we need to be familiar with in order to help us write the equation of a circle. And so as I look now at these problems down below, hopefully we're able to apply some of our understanding. And what I'm going to do is I'm going to look at this first one right here. I see that the center of my circle is at -1, -5. So this is h comma k. And what I also need to do is find the radius. And the radius is the distance from the center of the circle to the edge of the circle. And so in this distance, that is going to be 4, and that would be the same in any direction. It would be a distance of 4 from the center to the outer edge of the circle. So as I go to write the equation of my circle again, which is written as x minus h squared plus y minus k squared equals r squared, I just now merely substitute what I know for h and k. I know -1 has to go here, and I know that -5 has to go here, and I know that 4 has to go right there. So as I go to submit those, I write x minus, now be careful, this is -1, x minus -1 squared plus y minus -5 squared equal to 4 squared. And in doing so, these two minus signs in the middle are going to simplify, and that's going to turn out to be x plus 1 squared plus y plus 5 squared equal to 16, and this would be the equation of my circle up above, centered at -1, -5, with a radius of 16. So I'm going to pause the video, and I'm going to let you complete the next two and see if you can do it accurately. Hopefully you're able to finish those okay. Let's take a look at the second one. I just wrote x squared right here. You'll notice that the x coordinate is 0 of the center of the circle. So you could write x minus 0 squared if you wanted to, but you can just write x squared as x minus 0 is just the same thing as x. The y coordinate is +6, so I wrote y minus 6 squared, and then the radius was 6, and 6 squared is 36. And likewise on the second one, I got x minus 3 quantity squared, as the x coordinate of the center of my circle is 3. The y coordinate is 0, so I can just write y squared. Again, if you wrote y minus 0 squared, that's okay too. And then the radius was 8, the distance from the center of the circle to the edge of the circle. And so 8 squared is 64. So this is a formula, again, that you're going to have to be familiar with: the center of a circle, the radius of the circle, and how we apply that into this overall equation. So if this is something that you don't have down, make sure that's in your notes and that we can apply that moving forward. The rest of the lesson today is going to be very brief, and it's only going to be one more slide, and today is talking about applying similarities. So what can I do with similar triangles? And so it says here in the beginning paragraph that in previous lessons you've learned methods for finding similar triangles. And once you find triangles are similar, how does that help you? Why do we care about that? Today we're going to apply similar triangles in situations and solve new applications. So what we're going to do is we're actually going to go to the next problem, which is problem number 106. All right, moving on to the application problem of today then. It says Latoya was trying to take a picture of her family in front of the Big Ben clock tower in London. However, after she snapped the photo, she realized that the top of her father's head exactly blocked the top of the clock tower. While disappointed with the picture, Latoya thought she'd be able to estimate the height of the clock tower using her math knowledge. So let's just disregard all the absurd things in this problem, but just use some triangles to help us determine the measurements. If you haven't done so already, what I would encourage you to do is draw this diagram to the right over here, including all of this portion of it, and put that in your notebook, because we're going to use similar triangles to help us apply some understanding. And so the first question in part A says, hey, can you find any triangles that must be similar in this diagram? And at first glance, that may not be very evident, but what I want to draw your attention to is the fact that I can take and draw a straight line from that camera all the way to Big Ben. And if I were to draw a perpendicular line down here, I create a triangle, specifically a right triangle. And I can do the same thing right here. And so I really have two triangles embedded with one another. And what I mean by that is that they're really kind of overlapping. And I can throw some measurements on here. I know that this is 12 feet per this distance at the bottom. And from here to here is 930 feet. So that means all the way from here to here is 942 feet if I just added those two together. The distance above the ground of the camera is 2 feet. And so her dad is 6 feet tall, and so although this picture isn't drawn well, that would imply that this length right here is 4 feet. And what we're trying to determine is the height of Big Ben, which is this length right here, x, plus the 2 feet off of the ground that the camera is sitting. I know there's a lot of information being thrown around there, but the first question was stating, hey, are these two triangles similar to one another? And the answer is yes. I know that these triangles are similar by angle. And how do I know they're similar by angle? Well, this is a 90-degree angle here, and this is a 90-degree angle here, so that's one pair of triangles. The other pair of another pair of angles, rather. The other pair of angles that I have is this one right here. This overlaps with itself. That's shared by both triangles in the picture, and therefore those triangles are similar by angle. So how does that help me, or how does that help us in our cause to help us determine the height of Big Ben? Well, I can take this first triangle. We said that this was 12 and this was 4. And if I were to draw out the bigger triangle as such, we said this whole length on the bottom was 942, and I did not know the height of that other side, x. And since these triangles are similar, what we can do is we can write a proportion of sides. I can say that the side length 12 corresponds to 942, and the side length 4 corresponds to x. And as we've done several times, we can cross multiply these two quantities together, which is going to make 12x. And we're going to set that equal to 942 times 4. And when I type that into my calculator, I end up getting 3,768. Now we're going to divide both sides by 12. And in doing so, when we divide that by 12, we end up getting 314 for x. Now, one thing that we need to be careful of, that's this distance right here, 314. We need to remember that that's not the height of Big Ben, but we need to add 2 to that because the camera was 2 feet above the ground that Latoya was using. So we can say, therefore, that Big Ben was 300, or not was, but rather is 316 feet tall. And so we use similar triangles via angle to set up proportions and therefore solve for a missing side length. And so as we move forward for the rest of the week, bear in mind that Thursday, tomorrow, we're going to be having a Zoom meeting together as a class at 11:30 to be able to review for a test that we're going to be taking on Friday. As always, please let me know if you have any questions. I would love to discuss those with you, and you can swing by my office hours. Take care, stay safe, stay healthy.